what you're looking at is the average annual precipitation at Los Angeles, California, and Atlanta, Georgia. And you can see, actually, let me go over just to make sure you know what you're looking at. So here's January, February, March, April, so on and so forth. This bar graph indicates the average amount of precipitation each month. Okay, so here are in inches, so you get this idea. All right. Now, we talked about the global circulation model, right? And we said, or I said, that around 30 degrees north, it should be very dry and warm, right? Well, look at those. Now, before I point that out, LA, Atlanta. Atlanta's right here. It's the same latitude as Los Angeles. So what explains the big precipitation difference when both of them sit in the middle of the subtropical high pressure zone? We can explain it with the Bermuda High and the Gulf of Mexico. Remember, we got a Bermuda High, sits right here. Clockwise circulation, it sweeps this very warm, moist air up into the southeastern part of the United States, what we call the Gulf Coast or the Gulf States. So what you're seeing in Atlanta there is all of this humidity causes clouds and rainfall, despite the fact that both LA and Atlanta are on the same latitude. Okay, that's the difference. So I guess one of the points I want to make here is that the global circulation model explains most of the climates around the world, but it doesn't take into account these regional differences, like we have here. Warm pool of water, clockwise circulation moves that very moist air into the eastern half of the United States. Okay? Now, sticking with this model, let's go through these four zones one last time on this world map. This stick is the approximate position today of the intertropical convergence zone. All right. Now let's take a look at the climates around here. Tropical rainforest. Tropical rainforest. Tropical rainforest. Heavy precip. There's a couple of areas not so wet. Rain shadow effect in East Africa. They're not so wet. All across here is very wet. All right. For example, okay, so these are very tropical areas, all right? Now, let's go up to subtropical high pressure, up around 30 degrees north. So we stay in North America for a second. Well, I think we'll all agree it's very warm and dry, say, from about West Texas over in northern Mexico, subtropical high. We've explained away Bermuda High, bringing all that moist air. That's why the southeastern part of the United States isn't a desert or very warm and dry. Okay, let's carry it on over 30 degrees over here. What's under my stick? Sahara Desert. This northern Africa, this is one big desert, the Sahara Desert. That's totally explained by the global circulation model of descending air. Arabian Desert, same thing, okay? Now it's moisture over here because, again, we're getting warm, moist air coming up from the warm Indian Ocean, all right? Let's go down to the southern hemisphere. I don't talk about the southern hemisphere very much. Why? I'm going to put my stick on the equator. What's different about the northern and southern hemisphere?
Less stuff.
Less what?
Countries.
Less landmass. Do you know that 75% of the world's landmass lies north of the equator? So not that many folks live south of the equator. There's not much landmass down there. But let's take a look at it. Okay, let's take a look at, see, 30 degrees south should also have descending air. So 30 degrees south. Well, there are some dry areas here in South America, but so much of South America is surrounded by water. Its climate is influenced by the oceans quite a bit. Let's go to Africa. This part of Africa, Kalahari Desert, explains that. 30 degrees south. What about the climate in Australia? What do you know about that?
Very dry.
Almost all desert. So that's explained away by the global circulation model. So anyway, just to, to finish that, the global circulation model really does explain a lot of why climate is distributed the way it is.